Khaled would say yes too.
Sure, I agree.
Turn on the lights or it's okay?
I think it was fun.
It's okay.
It should be okay.
Good morning. Today is my oral exam for the Prelim PhD presentation. The committee members, Dr. Mike Pope, Dr. Mancini, and Dr. Sen and Dr. Thomas. The title of my work is Segmentology Sequence Stratigraphy of the Sri-Lankan Middle to Late Miocene rocks, the Jebel Qadar, Uplift, and Suluk Northeast Libya. Location and settings. The study area located in the northeast part of Libya, which is considered as the eastern part of the Mediterranean region. It's stable for land basin. And the rocks we are interested in are middle to late Miocene rocks. They are called the Rajma group, and they are divided into Benghazi Formation, which is the middle Miocene, and the Qatar Formation, or Wadi Qatar Formation, which is the late Miocene rocks. And the late Miocene rocks are between these red lines, which is two escarpments. This is the lower escarpment, and this is the upper escarpment. The middle Miocene is in the lower escarpment here, and the top of the upper escarpment. The proposed project, we are testing the hypothesis if this carbonated platform is a ramp setting or not. And for doing that, we intend to do sequence stratigraphic work based on segmentology, sequence stratigraphy, and time surfaces, stable isotope, chemostratigraphy, and also we use geophysical methods like gamma ray measurements. By doing this, we are going to integrate the original work, because our work is on original scale. We are going to integrate all of these measurements and observations to establish our sequence stratigraphic frame. And the other good thing about these outcrops, they have large extension of oolitic facies, more than 100 kilometers, which should be like good analog for subsurface carbonate reservoirs or lithic reservoirs. Methodology. We plan to do the work at two steps. The first step, which is the field work, the second step is the lab work. The field work has been done in last summer, 2012, from May to August. And my field assistants and I, we measured 25 stratigraphic sections and 14 gamma ray vertical profiles, and we did panoramic digital photomosaics, plus we collected 605 samples to use them in the second step for the lab work, to make thin sections, do petrographic work and diagnosis, and then decide where to take our stable isotope samples for oxygen and carbon stable isotopes. By gathering all these data together, we'll be able to make the stratigraphic framework or sequence stratigraphic framework of this study area based on the segmentology, stratigraphy, time surfaces, stable isotopes, and the vertical gamma ray profiles. Segmentology characteristics of the facies in the study area. We have two types of facies. We have carbonate facies and siliciclastic facies. The carbonates are 8 facies: oolitic greenstones, microbialites, red algae, coral reefs, bioplastic greenstones and backstones, lethal backstones and waxstones, evaporites and marley backstones and waxstones. The oolitic facies are the dominant facies in the late Miocene, the upper part, which extends more than 100 kilometers. It's thick, laterally extensive, showing molded porosity, very well bedded, cross-bedded, channeled. The microbialites are laminites, thrombolites, and stromatolites. The laminites and the stromatolites showing fenestral porosity and large bugs. And they are very thick but restricted to the southern part of the area. Borites, they are very thick but also still restricted to the eastern part of the area. This is the problem. There are restrictions for the facies. The bioclastics, backstones and grainstones are associated with all these species, but always they are limited in their vertical thickness, and they are not continuous lateral. The same thing with the little and evaporite facies. They are thick, but not lateral, continuous. And the same thing with the marley backstones and rockstones. Very local, thick, not lateral, continuous. The second type of facies is siliciclastics, which is marine green shale, quartz sandstone, and calcareous quartz sandstone. This calcareous quartz sandstone is basically oolitic grainstones with very fine quartz sandstone matrix. All of these facies are restricted to the southern part. They are thick to very thick. The marine green shale is green in color, very thinly bedded, and the previous workers, they find fish teeth and coprolites within these shale facies. I didn't see them. The quartz sandstone is very friable. It didn't show me any visible sedimentary structures, but always interbedded with the shale. The calcareous quartz sandstone, very well bedded, laminated, and always either in the middle of the shale facies or above it. Never been below it. To do the stratigraphic work and the correlation, the first step to do is just to make the 1D analysis. And here we have the stratigraphic log, lithology, and here we break it down into shallowing upward cycles that they find, and usually my shallowing upward cycles are topped with evaporites. And this is the gamma ray log that I measured in the heat from these logs. This is the first step to do. And by the way, here the unconformity surface between the middle and late Miocene in this part exactly.
Can't see it. Can you show me where it is? I just couldn't see it.
This part is very
If you touch the board, it'll go through.
okay.
So,
This one. And then, after picking the surfaces, I did the same thing for the other surfaces in the study area, or for the same section, for the other sections in the same area. And I end up with this, the maximum flooding surface. And I picked the surface above it and the surface below it based on the parasequences that I have, the surfaces and the gamma ray profiles. I tried to tie these things together to get this. And then I ended up with this stratigraphic section, which is more than 145 kilometers. This is the maximum flooding surface I have. The yellow is oolitic greenstone, and this yellow beige color, light brown. Very light brown is paleto ooids. And here I have the green shale with the sandstone in this part. These are corals. And also I have light brown and deep brown, which is the red algae. It's very dominant in the lower part, in the middle Miocene. But the deep brown ones are reworked, broken, fragmented, and the lighter brown are acidic.
This is the entire section.
Yeah, the whole section. But these are just nine sections from
So in
21.
there are those various, you have coursing upward,
Yeah. Shallowing the water cycle?
they're in here,
Yes. Shallowing the water cycle.
so show me one.
This evaporite, between this evaporite and this evaporite is one cycle shallow.
Oh.
This is the master key of what? This is the master key of the study area. Because it has the evaporites, and between the evaporites I have the shallow water cycles. So
So they're all higher order sequences.
Yes, but still,
Because you have one maximum flooding surface, right?
yes,
So these others are what, fourth or fifth order?
it should go fourth floor.
Are they always bracketed by evaporites, the parasequences?
That's what I find in this area, but in the other areas, no.
Oh, in this area?
Yeah, in this area, but I use this as a master key and guide for me to do correlation from south to north. Yeah, but this is the master key for me.
Okay.
And they have strange faces here. These thrombolites and stromatolites. They are very thick here, and I couldn't see them anywhere else. Just they're restricted to this area. And it shows me like very sharp change in facies. I don't feel good about it, but this is what I have.
So the maximum, the third order maximum flooding surface is going through where now?
The red color, the red line.
On top of the evaporites.
Yes.
So that's in also transgressive surface?
I didn't went that far in the
Okay.
recommendation. Just I did this quickly to understand what I have.
Okay.
But still, it's preliminary.
No, I don't know, I'm just asking, well, it could be, the transgressive surface and maximum flooding surface could merge.
Yeah. And the other
Could
thing,
be.
sometimes it meets with the conformal surface too. In the upper part, I have it here. When I added channels to this stratigraphic section, I find the lower part I have very thick channels. When you go up, they become smaller in thickness. And that could be decrease in accommodation. It's from minimum accommodation here. When you go up here, it becomes maximum accommodation. That means you have rising sea level. But when you go up in this part, it's flipping from maximum accommodation to lower accommodation or minimum accommodation. That means falling in sea level or decreasing the relative sea level. These coral reefs, this porites, and this we have shows the branching.
Oh.
The branching, yeah, the
Thank you.
branching in the porites. This is in that one in the eastern part of the study area, and this one is in the middle part of the study area. But this one is very local and limited in space, but that one is very extensive in the eastern part. Another picture for the porites. This is the outcrop here. This is the Jacob stuff, 1.5 meter. This is the whole outcrop, and this part is the blowout here. And just to show the branching of the porites. The whole section is just porites.
What is the
Almost, this is 1.5, almost 6 meters. Yeah. And there are 3 levels in that quarry. This is one of the levels, 6 meters. And the others like 8, 7 meters. Here again, we have porites, but it has channel. This channel, it has voids in the basal part, and it's going up into muddy facies, becomes smoke.
So what's the EOD?
Is what?
Environment deposition?
Zeolitic.
No, the channel.
The problem is I need to make sure if
Is it a tidal channel, a fluvial channel, a turrite channel? Or?
yeah, that's the point. I need to make sure the age of these voids, because if they are related to the late Miocene, because this middle Miocene, the porites, we're sure of that. But these channels are late Miocene channels or something else. So if they are late Miocene channels, that means the surface in between is the unconformed surface. But if the same age, could be the tidal channels. This is one of the problems that I faced in the field. I didn't know these facies age exactly. And I got samples from them to see what we have.
But you can't map laterally?
No, they're limited. Just
I know, but when it comes up, it just goes up to the top of the outcrop and it's gone?
there's no nothing above it. It's just
So all you got
road
is
cut.
a scoop. and that's
Yeah,
it.
just road cut. Unfortunately, I don't have the rest of the outcrop.
Yeah, okay.
Here's the red algae. Here's the small bits. It's another quarry. This is the marley packstones and limestone, but they are just covered with terrarosa, but all are marley. And we are lucky to have this road that shows us.
Is the Marley part down where your field assistant's sitting?
Is what?
Is that where your field assistant is sitting? Down there on the bottom?
Yes,
Marley part?
this one, yeah.
Okay, so what's the stuff just behind the field assistant? Is that still Marley?
Yeah, there's marley too, yeah. You can see. But here it's just covered with the soil wash. And there's marl too above here. But it's still covered with the soil. It's thick soil.
Is the marl volcanic? No.
Didn't see what that.
Hmm.
It just changes from wacky stone into packstone with very large echinoids. But it's very local, you know, you couldn't find it everywhere, just some places and then it's gone. Here the disconformity surface between the middle and late Miocene. And this is the picture, and here back for scale, and this is the blowout.
So where is it? Is it right across the hammer?
Yeah, this one exactly. This is sharp surface. This is bioclastic backstones. This one is echinoidal backstone in the middle Miocene, and this one oyster backstones in the late Miocene. And usually these oysters shaded with the evaporites and making fine evapor cycles most of the time. The evaporites, they have white evaporites. This one very strange, ripples. And I have another evaporite. This is the Jacob star stick. This one, 1.5. And this swallowtail selenitic gypsum, it goes up into paletal facies, wax stone, and then it goes paletal facies, packstones, and paletal facies start interbedding with the oolitic grainstones at the very top part.
So what does that mean about your evaporites?
Yeah.
When did your evaporites form?
This is selenitic, this is late Miocene.
But no, I mean, on your platform, during what part of sea level did they form?
Based on the correlation that they made, it should go,
Based on that outcrop? You
It's
just
out.
described it.
okay. It should be like the low stand time. But based on the stuff that they made for correlation, it's within the high stand system track.
Does it happen?
No.
Could that be your transgression?
Between because the polita are also, they are laterally, you know, interfingering with these evaporites.
Right, and you're shallowing up, what you said you wanted to
Yes.
pellets and then into ooze.
Yes.
So which one's shallower there? Evaporites or ooze?
The evaporites, sure.
Sure.
There's some big ones.
If they're subaqueous, yes, they are lithical, sure.
So that means when do those form? Or could they have formed? If you're subaqueous.
You mean low stand, high stand transfer?
Yeah.
Okay. If you have water flow, they should form during that time, should transgressive time.
Could be.
Or most, but they're not subca. So therefore they're not high stand.
If the supper is,
Therefore the evaporites that are bracketing your parasequence may actually be your deeper water.
and I have another problem with these evaporites. Sometimes I find them sharp surface at top and bottom. Sometimes just sharp surface at the base. and I have a hard time to include them to which sequence, the one below or one above. It's, you know, confusing me. Because it shows me two sharp surfaces.
Oh, I know. You know, in the old days, supposedly you could do isotopes on the evaporators. Strontium they were using? The group out of Texas. Yeah. We did work in Alabama, subsurface and evaporites, and we ran the isotopes to try to determine whether the so they was or whether they were soft. I didn't have much. Now, Linton Lands were, that's what it was. I don't know, you don't want to go back and collect them to do isotopes, so I guess it doesn't matter, does it?
Yeah, I got some examples from this.
Oh, you still have samples?
Yeah, from
You
this
might,
and this.
you might read those old papers,
Yeah, okay.
you know, just out of curiosity.
Yes, I'll do. But the people that worked it before me, they say these are ponds because these evaporites, yes, they have too much thickness, but they're very limited laterally, and they interpret it as ponds, not too big, you know, basins.
How thick is that? And is that face of evaporates 5-6 years?
Yeah, it's more. Yeah. But laterally, it's like within like 200 meters or 300 meters is gone.
The question becomes, to make that much evaporates, you gotta have a lot of seawater.
Yes.
Right? So how do you get that much seawater in the high school? The sea level's falling.
How much did what?
The sea level's already on a fall.
Okay.
It's filling up that basin to get the sea level. So that's why we need to think about whether that's formed. Because it will be important for the theory accuracy and strength.
These microbialites, this one is the thrombolites and this one is the stromatolites. And I measured the long axis for these species. And they're, you know, rotating through time. The oolitic gravenstones, this one is opal, and this one show two sets of cross-bedding. Again, the oolitic gravenstone shows me climbing block, and it has bottom set and top set. And within this, we have channels with soft sediment deformation. And this card for scale. This is close to the type section of the middle and late life cycle.
Do that cliniforms too, as they come.
All oolitic, just changing grain size, scoring.
Well, what's happening is they come into this soft sediment deformation, where are they going?
These channels with soft sediment deformation. I measured that.
And are they still living?
Yes, all oolitic, never changing, just this grain size changing. It's getting coarser off.
But it looks like the angles of those cliniform. If it was a channel, you would think it would change direction. I don't know. Doesn't it?
Yeah, it does. It looks odd. It looks like you've got the cliniforms going this direction and the channel sort of coming.
Yeah.
Just 90 degrees to it, which is,
The direction is southeast.
so it seems like the later channel.
Yeah.
Which some one sea level fell or something.
Some cut through and then the channel was filled.
Beautiful.
Here, this is the top surface of trough cross-bedding. And here, this is the honeycomb cross-bedding. It's too big for it. Now the siliciclastic part, the quarry that we're finding the siliciclastics start with the green shale up to here until this white horizon, which is the calcareous sandstone, which is oolitic with sandstone matrix, and then it goes back into shale, and then sand, and then shale, and at this white second horizon it starts carbonating again. On a got zoomed in from this part, which is here. This is the sandstone, which is white gray, and here the green shade, what I was originally covering. This is the problem here for scale.
He's 8 foot tall.
I think he is 180 centimeters. For this section, what I did, I have the gamma ray readings from here to the top of the shale. What I did was discussing this subject with Marcelo. It was yesterday, telling him that I have shale and need to make confirmation. Some people saying it's fish, it has fish teeth and coprolites, but I need to make confirmation. Is it really marine or just, you know, lacustrine or something? And he told me about this paper, which is Adams and Weaver, 1958, and they have this beautiful diagram. I just pulled up my data, which is thorium, uranium, and thorium-uranium ratio. This part is the thorium-uranium ratio, and this part is the thorium. And my data fell down within this marine green shale and this within this marine shale. So it proves for me that I have marine shale, at least from the gamma ray readings for thorium and uranium.
That's interesting.
Yeah, before yesterday I didn't know about it. Just I got it this day.
His little camera reading can die.
Yeah, one of the data set was to come up with a diagram.
Interesting.
1958.
Yeah, and the other thing he has here evaporates, and my sequence shows some demographic
There
inclusion.
hasn't been anything more recent than that.
I'm sure there has.
Yeah, I'm sure there is, but they got it just yesterday, the last minute, and I need to make confirmation, to confirm what I have.
Well, that may be the paper.
Yeah, I start with it, just, even I didn't finish reading it, just I got the idea of what they're talking about. And in conclusion, what we are going to do with this work, just to establish the sequence stratigraphic framework and positional setting for this sequence, and then interpreting the body climate through the stabilized of data, and then publishing 3 papers at least for sequence stratigraphy, the positional environments, and diagenesis, and 4 page one.